If you've ever sent a letter through the mail, you know that you needed to write two different addresses on the envelope, a destination address and a return address. The destination address told the post office where to deliver the letter, and the return address told the recipient how to send a return message. And when you send and receive information on a computer network, addressing works in a similar manner. A network address is a unique identifier for a computer on a network. These addresses will be used by other computers to send messages across the network. Now, there are two main types of network addresses: MAC addresses and IP addresses. Now, each network adapter has a unique MAC address. MAC is short for Media Access Control, and it's not related specifically to the Apple Mac computers. A MAC address contains 6 bytes, and it's commonly written in hexadecimal format, with each byte separated by colons or dashes. The first 3 bytes represent the company that made the adapter. Each hardware company is assigned their 3-byte identifier by an Internet Standards Group. The manufacturer then calculates the remaining 3 bytes on their own, like a serial number, to uniquely represent the adapters being made by that company. You can find out the MAC address of the adapter in your computer quite simply. On Windows, open a command prompt and type ipconfig/all. You'll receive a bunch of information, including a line that says physical address. This is the MAC address of your network adapter. On a Mac OS computer, open System Preferences. Click on Network and then the Advanced button. Finally, select the Hardware tab. You'll see the MAC address listed on that form. MAC addresses can uniquely identify a computer on a LAN, but nobody really knows how to match up a MAC address to a target computer from further away. Now that's why a second set of unique identifiers called IP addresses are used. And there are a few versions of the IP address, but the most commonly used today is the Internet Protocol version 4, or IPv4 for short. An IPv4 address is a 4-byte identifier commonly written in decimal form. Each byte is separated by a dot. You can represent over 4 billion IP addresses with 4 bytes, which sounds like a lot, but those IP addresses are rapidly getting assigned to the many different connected devices that we have in today's digital age. The solution to the IPv4 shortage is a new standard called IPv6. In this version, we use 16 bytes instead of 4, so the range of possible values is truly staggering. You can make over 3.4 times 10 to the 38th power different combinations with 16 bytes. Now, IPv6 addresses are written as hex numbers in 2-byte groups separated by colons. Some of these groups might contain zeros, so it's common to leave these out when writing the values, although they are present in the actual address.